In this video, we are going to discuss about how to do the experiment Wien bridge oscillator using multisim. For that, you go to the multisim software. So it is a 13.0 version. So you expand this window. So you can see these are the design toolbox, spreadsheet, SpiceNet and all. So you go to the menu bar. In that, you click on the place button. Okay. So inside the place button, you can see there is a component. So in the component, you have a master database. So master database, below that one you have all groups, and the component you can if you you can see there is a symbol. So the symbol is now it is showing like this, right? So instead of all groups, you select the basic. Inside the basic, you can see you have several components. You select resistors. So here I require nearly four resistance. So you just click the 5K and give OK. And since I require nearly 4 resistance, now I can give OK. So now OK, and I'm placing the components. Okay. So if you see later on, we can arrange the components. Okay. So if you want to select the capacitor, you go to the capacitance and click OK. So here also I require nearly 2 capacitance. So I'm just giving like this. Okay. So after that, you can give you can close the if I have selected 2 capacitance, you can close the window. So next, I require power source, right? So for that one, you go to the source and click on the power source. For example, you have a DC source. So the DC source will look like this. So before doing this experiment, you want next ground. Okay. So before going to the experiment, you have to select which of the component are required. Okay. So just giving an example, here we require only VCC and V, right, for op amp, right, for so you can select VCC and V. Okay. So next I want to select the op amp, right? So you just give it 741 and place the component in that workplace. Okay. So after placing all the components, we can arrange the component accordingly based on the circuit diagram. So the circuit diagram was must. So if I want to connect this one, I have to connect like this. Okay, this is just for example and connecting. Okay, so if I want to connect just two, so if I want to connect it parallelly, you can connect like this. Okay, just using a mouse, you can do. And so you have the circuit diagram. Once if you have a circuit diagram, you can connect it easily, right? So if I want to connect these two components, you can do it like this. If there is some mistakes, means we can delete that one. Okay, you can select this and delete. So in the right corner, you can see there is an oscilloscope is there. So you can select an oscilloscope and give there are 2 channel oscilloscope, A and B. So one end is connected to ground and another end is connected to the output of the op amp. Next, we will do the connections. First, I am connecting the gain terminal. So this is connected since the feedback part is connected to the positive terminal, right? Because it is a oscillator. So RC and RC component come up on the positive only. This is gain part, and they have to connect it to a inverting terminal, right? So you just drag and place it like this. Next, let us go for the feedback terminal. So if you want to rotate, you select this one, and you can rotate it either clockwise or negative or anti-clockwise. That is counter-clockwise. Okay, this can be done like this. Next, this is connected to a, so this is not required. Next, the feedback terminal is connected to the output, right? And this is connected to the positive terminal, right? Next, I want to rotate this one to 90 degree, right? Because R and C are connected in parallel, right? So if you are able to do some 3 to 4 experiments, this, you'd be expert on this one, okay, in connection. So make sure all the points are connected properly. So, and this one is connected to the ground terminal. So this Wien bridge oscillator is also called as lead lag oscillator. So I need to place VCC on ground. So you just select VCC, and it must be 12 volt, right? So you can see initially the default value is 5, and the V in default value is -5. And you close this one, and the positive is connected to 7, and if negative is connected to 4, fourth terminal. So here you can see there is no input because it is an oscillator, right? That is, I mean, there is no function related. So this Wien bridge oscillator will generate a sine wave, right? So if I want to change the component of the capacitance, you go to the WK value of the capacitance and you give. So here I am using 0.1 microfarad. So this is how you have to edit it for the all the capacitance value and also for the resistance value. So the resistance value is 330 ohm. Okay, feedback resistance. So you just edit the values. Okay, and similarly you can do it for the supply also, right? So this value you can put it in your you can use it for the normal exponent also, right? So here you can change the RF value. The RF value must be always greater than R1 value. So it give it has 100K and this one has 47K. Okay. So change the capacitance always 330 ohm, and I have to change the. If you want, you can save it as um, by the name as Wien bridge oscillator. Wien bridge. So this is oscillator. So you can see there is no output, right? Because so if you want no ice cream, you click reverse. Okay. So I need to change that value, and I have to change the supply voltage, and after that I would give the run, right? So the supply voltage I am giving it as 12 volt. That's a DC value, right? And this one has minus 12 volt. Okay. Then if you see, you will not get any output because you have to press the run button. So the run button is nothing but a inverted triangle, right? The green button. You can see it. So near to that one, we have a pause button also, and they have a stop button. Okay. So instead that is also instead of two channel oscilloscope, if you want to take more output, means you can choose the 4-channel oscilloscope also. Now by pressing the run button, so if you see, I have some output, so it is running faster, so I'm reducing the time scale. So if I reduce the time scale, it is generating a sine wave. Okay. So if I want to reduce the magnitude, we can change the scale. Okay. And if I want to increase and decrease the frequency, also you can change it during the time scale. Okay. So if you want to save that value, you can save it like this. Okay. So let me pass the value. So if I want to find the value of time, that is frequency, you can adjust the first and second value, right? So this is how you will generally calculate the frequency, right? So you can see the difference between the two time periods, 217 microseconds. So if you invert that value, you will get the frequency, right? So here the frequency is nothing but f is equal to 100 by 2 pi RC. So similar way, I can also find the value of the voltage, right? Here the peak to peak voltage, that is it is shown in the channel A, right? So once if you adjust the value of the 1 and 2, that is the red and black line, so you can adjust, you can get the value of a V peak to peak value. So here it is showing 22.189, right? So if I want to find the RMS value, means RMS is nothing but V peak divided by root 2 value. So 22.189 is nothing but V peak to peak value. Half of the value is nothing but V peak. So if I also divide it by root 2, means I will get the value of VRMS value. Okay. Since the output is nothing but AC series. So this is how we have to calculate the frequency value and magnitude value. So I hope this video is useful for you.